This is 2009 FRQ number 2, still in the calculator portion. All right. So the rate at which people enters an auditorium for a rock concert is modeled by the function r, given by r of t equals 1380 t squared minus 675 t cubed between 0 to 2 hours. R of t is measured in people per hour, so r of t is already a rate. And no one is in the auditorium at time t equals 0. Perfect. When the doors open, the door closes and the concert begins at the time t equals 2. So the door was only open, the people were waiting in line between t equals 0 and t equals 2. Because when t equals 2, door open and the concert starts. Okay, so how many people are in the auditorium when the concert begins? So people are going in at t equals 0, right? And then they stop going in at t equals 2 because the concert starts. So to find out the total number of people in the auditorium, you take the integral between 0 to 2 r of t dt, all right, 0 to 2, 1380 t squared minus 675 t cubed, and dt. Plug that into our calculator, or you can do a derivative if you really feel you want to do that. 1380 t squared minus 675 t cubed, comma t, comma x, 0, 2. All right, so let's take a quick look. That gives us 980 people. All right, so 980 people. All right, well, not a super big concert. For part B, find the time when the rate at which people enter the auditorium is a maximum. So we're looking for the maximum of the rate, which means we need to take the derivative of that RT, right? Because you're trying to find the maximum of anything, you want to take the derivative of that and then find the extrema, right? So for part B, we go ahead and take the derivative of R, so R prime of T, 2 times 1380, so that's 2760 T minus 3 times 675, that's 2025 T squared, right? So how do you find the maximum? Set that equal to 0, so 0 equals T times 2760 minus 2025 T, all right? So we're gonna set these equal to 0, you get T equals 0, and T equals this awesome fraction, 2760 over 2025, and if you divide it through, it's about 1.363. Right? It's not a really clean fraction, so we're gonna leave it as 1.363. Okay, so how do we know if this is a maximum? To know that this is a maximum, you then check the concavity of it, which means you need to take another derivative, right? So let's check the concavity at this point, see if it is truly a maximum. So R double prime of T is 2760 minus 4050 T. And then now we plug in 1.363. We get 2760 minus 4050 times 1.363. You don't even need to work it out. You can see that the answer is going to be negative, which means it concaves down, which means we truly have a maximum, right? So last but not least, because there is an endpoint to this, right? Because you have an endpoint at t equals 0 and an endpoint at t equals 2, you also have to check the endpoint to see if you truly have a maximum. So you want to check R of 0, R of 1.363, and R of 2, right? Our endpoints are 0 and 2. Well, we know at R at t equals 0, there should be 0, right? And if you plug in 0 into your function, the R of t function, you'll get 0 anyway, so we got that. You plug in 1.363 into the R function, you get 854.527. If you plug in 2, you get 120, so it proves to you that 1.363 is our maximum. So the rate is at a max when t equals 1.363 hours. Okay. In part C, it wants the total wait time for all people in the auditorium by adding each person's waiting time, starting at the time the person enters the auditorium, ending when the concert begins. The function W models the total wait time for all people who enters the auditorium before time t. The derivative W is given by W prime of t equals 2 minus t R of t. Find W of 2 minus W of 1, the total wait time for those who enter the auditorium after 1 hour. All right, so let's ignore this first. Let's look at W prime of t. All right, so they didn't give us the W function. If they had given us a W function, we could very well plug in W of 2 minus W of 1 to get us what they want, W of 2 minus W of 1. But they, instead of W, they gave us W prime. But we do have a very good tool. The integral of W prime will give me W, right? And so in other words, if I go integrate between 1 to 2, W prime of t, that will give me W of 2 minus W of 1, right? Because when I take the antiderivative, it becomes W, and then I need to plug in the 2, plug in the 1. So in order for me to find that, this will give me the answer of W of 2 minus W of 1. Okay, now, what do I know about W prime of t? It says W prime of t is defined as 2 minus t r of t. So in other words, this is the integral between 1 to 2, 2 minus t r of t dt. If I can find that, this is the same as that piece. Therefore, it's going to give me W of 2 minus W of 1, right? So then again, your calculator is very handy. I just have an extra function now, okay? So I am going to go math 9. I'll punch in the first one, 2 minus t, or 2 minus x. And then parentheses, the other function, r of x. So 1380 x squared minus 675 x to the third, close parentheses, comma x, comma 1, comma 2, right? Because I want 1 to 2 now. All right, so if I press enter, I get a total of wait time of 387.5 hours. That's a lot of hours waiting for a concert. All right, last one. Okay, on the average, how long does a person wait in the auditorium for the concert to begin? Consider all people now. See, before we only considered people who were waiting from first hour to second hour. Now we're going to start at 0 hour, right? Use a model for total wait time from part C. All right, so now we want from 0 to 2 of the wait time, 2 minus t r of t dt. And then when I find that, I need to find the average. So take this and divide it by the average of 980 people, right? That way I know how much time did each person wait. Okay. So I have this function already from part C. I really don't want to retype everything. The only change is the 0 to 2 instead of 1 to 2. So if you didn't know this already, just press second enter. It's going to retype everything. And I can go ahead and go in and readjust this to 0 and press enter. 760. Now divide that by 980 people. So 760 divided by 980 people gives me 0.776 hours, right? And if you want, you know, that's hours. So really each person waited 46.531 minutes. Again, that's a lot of time. All right, that's it.